Hi, so we're going to talk about inverse sine, cosine, and tangent functions, kind of introducing solving equations with trig functions. So you will need a calculator and make sure that you have access to either write down your notes, have your unit circle, and those kind of things. So let's just kind of get started here. So we are going to use the unit circle to find the exact values of the angle. So a lot of times now we will be given a ratio of sides. So we're going to be asked to find inverse functions and have to be able to find what angle measures they go with. And when we want exact, you have to use this unit circle. Where to look on the unit circle is very important. For sine inverse and tan inverse, you're going to look in the quadrants 1 and 4. So really down that whole right side of the unit circle. For cosine, you're going to look in quadrants 1 and 2. The reason that is if you look over here, cosine values are exactly the same in these two quadrants. So that's why we want to look in these two where the cosine values run the whole gamut of what they can be. And then sine and tan are opposite values here. So we'll look for sine and tan within these two quadrants and cosine within these two quadrants. So let's do a couple of practice ones. So I do want to mark for you guys to realize this. Arctan and tan inverse are asking you to do the exact same thing. So arcsine, sine inverse, arccosine, cosine inverse. These are asking you all to find angle measures, which is in trig we call theta. Our first example here, arcsine of square root 2 over 2. Once again, for sine inverse, so that's these two right here, we are looking within quadrants 1 and 4. So in quadrants 1 and 4, where is sine the positive root 2 over 2? It's at this angle right here. So it's either 45 degrees or pi over 4. Now, if you will notice, it doesn't actually say, so it really doesn't matter to me which way you go about writing this. You could write it as 45 degrees, or you could write it as pi over 4. That was right on top of each other. Sorry, let's see if I can make that a little bit neater for us. So 45 degrees or pi over 4. One's in degrees, one's in radians. It really doesn't matter to me unless the directions specifically tell you what to put it in. All right, now we're going to do sine inverse of -1. So once again, quadrants 1 and 4. Where is sine -1? Remember, sine is our second value. I should have pointed that out. We're looking for where's our second value, -1. So it's right here, which is 270 degrees or 3 pi over 2. Now the problem with that is that is going clear around this way. So we are actually coming backwards. So this is where we're going to use a negative angle measure, and it gets a little bit trickier here. So what I'm going to do here real fast is just kind of show you. So right here, we need to figure out what would we have to subtract from 360 to get to these angles. So for example, this one right here, we'd have to subtract 30. That's why this one would actually be -30 degrees. This one would be a -45 degrees. This would be a -60 degrees. And this would be a -90 degrees. Remember, negative means we're going backwards. Here's the other thing you think about, is they are just a reflection of the angles right above. They would just be negative of those, including the radian one. But anyway, what we're looking for is right here. So it's a -90 degrees or a negative pi over 2. So if we come back here, we're looking at this as a -90 degrees or a negative pi over 2. Let's do another couple examples. Now we're doing with the cosines. So cosine being our x value. So we're looking for where's cosine a positive root 2 over 2 and where's cosine a -1. So let's go back over here. A positive root 2 would be root 2 over 2 would be right here, and a -1 would be over here. So let's start with this one. So positive root 2 over 2 is once again pi over 4 or 45 degrees. And these ones will always be positive. So pi over 4 or 45 degrees, either one. So then this one If we were to look at -1 again, -1 flying all the way over here to our x value is pi, or 180 degrees. And since we are always looking in these two, these angles will always be positive. So it'll be a positive pi, or 180 degrees. Once again, either answer is fine. I have no preference between the two. All right, arctan. So the easiest way to think about this is tan is sine over cosine. Sine over cosine. So we've got to find where √3 over 1. This gets a little bit trickier. I'm going to come back to this slide, and we're going to talk about how do we look at this. If you look at the denominators being the same, you can ignore the denominators and see, okay, where's these tops divided? So like tan on this one would actually be 1 over √3. You just do sine divided by cosine. This one would be √2 over √2, which in this case happens to be 1. And then on this one right here, it would be √3 over 1, which, hey, that's actually the one we're looking for. So tan of √3 over 1 would be pi over 3, or 60 degrees. So this one right here, we'd say it's pi over 3, or 60 degrees. Either of those are okay, and once again, you can write it either way. Now, the last thing, that's if you're finding exact values. So we'll point that out. Exact values. What happens if you need to find them in the calculator? This all depends on what mode your calculator is in of how you're going to get it. So cosine inverse of -0.49 basically. So we're going to come down here to the calculator. If you click mode, you can see what mode you're in. Right now I'm in radians. So let's do this. So to find your inverse functions, and what was I trying to find? Cosine. Okay. So I'm going to do second cosine. That gives me that inverse. You do not want to do a 2 then -1. That will not give you the same thing. And then -0.9999. This is going to give my answer in radians. So 3.13 is kind of our approximation. So we'd write this as 3.13, 10th, 100th, 1000th. It actually wants 3 decimals. So 3.127 be what that actually is. So let's fix that. 3.127. And that one, like I said, is in radians. So as long you don't have to write radian, as long as there's not a degree symbol, you're fine. But let's say I wanted to find it in degrees. So I'm going to come down here and convert this to degrees. So I could go back up here, grab that, and it's 179.18, well, this would round up, so 190 degrees. 179, 190. So, like I said, 179.190 degrees. So either answer is fine, and you would go through, and all 3 of these are available on the calculator. So you could just go through and type all those answers in. So second sine, or second tan, and remember that arctan and that tan inverse are the exact same thing. And pay attention to the directions to determine where it wants you to round. So in this case, thousandth would be 3 decimal spots. So we have 3 decimal spots. All right, I hope this helps. I'm not going to actually do these two. I'll leave you for those, and then I'll put those answers in the actual notes that I put on Google Classroom for you guys. So you can try them on your own and see.